Hello children, in today's class we will be discussing the directions of a vector. Children, we know that a vector has a direction. Mainly whenever we talk about a vector, yes, we will be very particular about the direction. But whenever we are giving a direction to a particular vector, so how we are taking that particular direction is a very important. So this is a very small topic. Directly questions, may not be asked from this. But whenever there are some numericals where angle between two vectors is involved, definitely they will add this concept also. So it's very important to us to learn how directions are taken for vectors. Children, we know that there are four directions, right? So here south, east, north, west. These are anti-clockwise. Whereas south, west, north, east, these are clockwise direction. These four directions are also called as cardinal directions. And other than this, we have four more, right? Means halfway of east north, one more direction is there. Halfway of northeast, one more direction is there. Halfway of southwest, one more direction is there. Halfway of east south, one more direction is there. Okay, we will come to that other four directions later, little bit later. So, children, whenever we are talking about any vector, for suppose let us take a force. For suppose it is given that 5 newtons force in a east direction. So, 5 Newton force acting on a body in a east direction. So, we will take a scale, right? For suppose here 1 centimeter, if we can take as a 1 Newton, then 5 centimeters will be equal to 5 Newton. So, when you want to draw a force vector with a magnitude 5 newtons towards east, so we will take a 5 newtons. Okay, let us suppose from here to the 5 newtons. So till here, so we can let us say it's a F is equal to 5 newtons, which means what? 5 Newton force is acting, okay, towards east. If it is acting towards north, yes, we will take in this direction 5 Newton force. Okay, if it is a 5 Newton is acting towards west, yes, 5 newtons in this direction. The same force is acting towards the south, exactly 5 newtons we will take towards the south. It's fine. But are we sure that always the force acting along these four directions? No. So if it is other than these four directions, if force acting, yes, other than these four directions means yes, there are four directions. So halfway of east north is there, halfway of northwest is there, halfway of west south is there, halfway of southeast is there. So children, we know very well that the angle between either northeast or northwest or west south or southeast is exactly 90 degrees. And halfway of northeast, halfway of east and north, this we can northeast. So exactly this will be 45 degrees, right? Yes, exactly. Okay, na? Okay. But here the doubt is that should we call it as a northeast or east north? Okay, first let us write it can be northeast or east north. So however this children, so this can be northwest or west north. So this will be southwest or west south. This can be southeast or east south. So on what base actually we write either it is a northeast or east north? You may get one doubt, sir, either northeast or east north, both represent the same one, right? Yes, it represents the same, but direction is very important. Are we moving from north to east or east to north is very important. Children, see, though we students can practice this again and again, always there will be confusion. Is it northeast or east north? Children, for this, I'll give you a clue. If you can remember, if you can follow this clue, you never forget, you never have a confusion in terms of directions. That is, just let us recall letter writing, children. Did you write any time letter to anyone? Okay, I don't know whether your generation, I don't know whether you have written or not. Yes, we have written, we wrote letters, right? Okay. Anyhow, whether you write or not also, up to definitely in a 10th class, 11th class, as you will be having English subject, their letter writing will be there. Children, whenever we are writing a letter, the two common things will be there. What is that? To address, okay, na? From address, right? This is very important. You may get one doubt, sir, why we are talking about English in physics? Yes, I am coming to that point only. To address, from address. First, what will you write? To address. Then from address will come. So where that letter has to go should come first, and where that letter is coming from should come second. I repeat once again. So to where you are sending that letter to, that should come first. From where that letter is going, that should come second. Is it clear? Fine. Now, for example here, if a particular person is going from A to B, again I repeat, a person is walking from A to B, B. So this is from, particular person is coming from, going to B, So this should come first, this should come first, this should come second when we are writing. Even when we are writing the directions of vector also, this is what actually we are going to follow. Is it clear? Fine. Now let me give you a clarity now. So you may get a one doubt, sir, it is 45 degrees, this you know very well, 45 degrees. But if it is from like this, yes. So here you are moving from east to, east to north, east from east to north. So the 2 should come from, right? Yes. So this I can write as a 45 degrees north. From where? East. Children, very important. Very simple to understand. So we are moving east to north. 2 should come first. Then from where you are coming? East. So this is 45 degrees north of east. 45 degrees north of east. If it is like this, look at it. Okay, na? So this, let us say, is the first example. Now this is second case. In the second case, from where you are coming? We are coming from north, moving to east. So east should come, right? So 45 degrees east of west. East of north. East of north. So this first one represents where you are moving, in which direction that particular vector is moving. That should come here. From which direction that particular vector is coming? From. So if you have idea about this point, this particular small thing, then we never have a confusion at all whenever we are taking the directions. Is it clear? So again I am telling you, first 2 should come, where, in which direction it is moving actually. Okay, na? And second one, what should come? From where that particular vector. So this, if you can take this first case, moving from east to north, that's what we can write, 45 degrees. So 5 Newton force, 45 degrees north of east. Whereas second one, it will be 45 degrees east of north. So where? To, from. I repeat once, to, from. So if you have this point in your mind, you don't have a confusion at all. Clear? Fine. And children, okay, this 4 plus 4, 8 direction. But are we sure that only that particular vectors are, always moving in between these 8 directions, or these 8 directions are involved? No, other than these directions are also involved. But how to write? Yes, let us see here. Let us take one more example so that it will be very easy to us. Of east. Yes, look at here. So let us try to write the vectors direction for this. So first it is given 5 Newton force, 37 degrees. So 5 Newton force is acting at 37 degrees east of north. So look at here. So let us take 4 directions. Yes. Okay. This is east, west. So here is north and here is south. So here only east and north, these 2 are involved. Okay. So 37 degrees east, children, to, from. So before it is like this actually, north. So actually it is. So now it is inclined towards east like this, 37 degrees. Okay. So from north it is 37 degrees towards east. So this can be like this. So here is 37 degrees 5 Newton force. So east to, this again I repeat, this is to, this is from, this is from. Clear? Fine. Now second one, 2 meter per second, 30 degrees west north. So let us take now, here is west north only, right? Yes, no need all direction. This is north and here is west. So they are saying that 30 degrees west of north means Before it was like this actually. So this vector, so let us say there is a velocity vector is turned towards west by 20 degrees like this. So from north towards west it can be, yes, this is, so this is 2 meters per second. This is how much, the 30 degrees. Fine. Now look at here, 10 meter per second square acceleration, 25 degrees south of east. So south of east, okay, here it is there, okay, look at here, let us take this one here only, okay. So 25 degrees south of east means actually the acceleration vector is towards east only actually. Now it is rotated by 25 degrees towards south. So towards south, let me just wait, towards, so this is 10 meter per second square, this is 25 degrees. Children, it is as simple as that. Don't get confused in which direction it is moving, from which direction it is coming. So to which direction it is moving, it should come first. Then second, from which direction it is coming, that should come second. Is that clear? So this is 5 newtons, 37 degrees east of north, 2 meter per second, 30 degrees west of north, and 10 meter per second square, 25 degrees south of east. Just copy this. It will see 3 more important points regarding vectors. Okay, just copy this. Yes, this is vector B. Children, these 3 points are very important. Okay, so first one is what? I am rotating any vector by 360 degrees or 2 pi radian, 2 pi, okay, now it does not change, which means what? For suppose here, it is a vector, let us say towards east, that is a 5 Newton force is acting towards east. So if it is rotated, for example, it is here by 360 degrees, which means what? Like this, like this. So 360 degrees it is rotated. Again, what will happen? It will come to the same position. So there is no change in magnitude, there is no change in direction. So any vector, if it is rotated by 360 degrees or 2 pi, so there won't be any change in it. Okay, fine. And the second point is that parallel shifting of vector. This is very important actually, mostly. So we will be following this only. Parallel shifting means what actually? If a vector is, okay, it's a 5 Newton. So this vector can be drawn like this also. This vector can be drawn like this also. So direction is east only. Magnitude is 5 Newton. So without changing its magnitude and the direction, you can draw that particular vector anywhere. So look at here. So this vector A, let us say it's a 5 meter velocity vector, 5 meter per second in this direction is acting. So same vector can be drawn here, can be drawn here, can be drawn here, means that parallel shifting can be accepted. Let us take here, let us take the first example. So in this example, more clarity you will get. So that particular velocity vector is 2 meter per second is magnitude, is acting such a way that it makes 30 degrees with the x-axis. Okay, sorry, 40 degrees with the x-axis. Now same vector can be drawn here. So same vector is drawn here such that the magnitude is same only, and still it is making 40 degrees with the x-axis only. So parallel shifting of vector is accepted. Okay, fine. Third one, very important. So mostly, as I told you, that the direction concept is mixed with the angle between the two vectors, and the questions can be asked. Yes, we will do 2 more questions, 2 numericals we will do, so that you get a more clarity. So angle between the two vectors. Children, first point is that there are 2 conditions. So whenever we are taking the angle, make sure that two tails should be in contact. First condition. And the second one, the angle should not exceed 180 degrees. So look at here. Yes. So these 2 vectors, yes, their 2 tails are meeting. Tail by tail. Okay. So it's a t square method. Tail by tail. Okay. So yes, now here is the angle is 30 degrees only. No problem at all. But here you cannot take it as 120 degrees. Why? Here, see, first vector head is in contact with the second vector tail. So it is not accepted. Then what we have to do? Parallel shifting. Yes, this vector can be shifted parallel to itself like this. Okay, yes. So then this will be the angle. This will be how much? Theta is equal to 60 degrees. This will be 60 degrees. Okay, now, or this vector B you can draw, you can just pull it back here. This vector you can just either tail by tail or head by head, no problem. So this will be the angle 60 degrees. Anything is okay. Don't get confused here. Okay, now look at here. So here is one vector is like this, let us say vector C, and here is, it is given one more vector, let me draw here. So what happened today? Yes, wait, let me draw one more vector. It is going. So for suppose it is given like this. So this angle is, for example, 320 degrees. Now by seeing this, so you may think like this, sir, anyhow these two tails are meeting. So this angle between, no, you cannot take. Why? The condition is that they should not exceed 180 degrees. Then what we have to? Yes, so this will be the angle. This will be the angle. So this is how much it is? So 40 degrees is the angle between these two vectors. Is it clear? Now we do two important numericals. So after that you will get 100% grip on this. Just copy this. Fine. So just you can see the question on the board, children. So according to this question, it is given that a man walks towards east with a certain velocity. So first let us take here is direct. Children, taking the directions are very important. So after that only we are able to find the angles. Okay, now so look at here. So it is east, it is north, and here is west, and here is south. So the person is going like this, children. So this is the direction of a man. Okay, so man walks towards the east with a certain velocity. Vm is the velocity of that particular person, magnitude we are talking, but towards the, okay, let us keep here arrow mark also because it's vector, we are talking about direction also. And it is given that one more car, so it is going with certain velocity, okay, now, such that it is going a road, it is 30 degrees west of north. Children, west of north means towards west from north. Very this is very important here. So this is, so west of north, west towards west, okay, of north means from, this is 30 degrees. This is what actually velocity of car. Here is velocity of a car. And one more bus is going along another road such that it makes 60 degrees south of west. South of west means towards south it is. So this is, okay, so towards south of west. So it is given that 60 degrees south of west. So this what actually velocity of, what happened to this marker? So this is velocity of bus. So this what, see that's what I said actually. If you want to do this question, first you should know how to take the angle or directions. So this is 30 degrees west of north. This is 60 degrees south of west. Now the question is that what is the angle between velocity vector of man to this car to the bus velocity to the man velocity. So first we drew like this. Now it's almost the answer is clear to us now. So anyhow, if you can see this vector, okay, velocity of man, velocity of a car, yes, tails are meeting, no problem at all. So this is 30 degrees and this is 90 degrees. So this total is how much, children? This total. So the angle between velocity of man and velocity of a car is how much? 90 plus 30 is how much? 120 degrees. Fine. Now what is the angle between car or velocity of the car to the velocity of the bus? So this is how much? So velocity of the car here is velocity of the bus it is. So this is 60, this is 30. So this will be how much, children? This is 60 again. So this total is how much? This is 60 again. 60 plus 60. Yes, it is 120. Okay. Next, velocity of the bus, angle between velocity of bus to the velocity of man. This will be how much, if you can see? So this is 90. Okay. So 60 gone. So this will be how much, children? This is 30. This, now they are asking this angle, right? So 30 plus 90, 120. So it is not that always you will get the same angle. So depends in the data given. So now we are able to take the angles. Why? How we are able to take the angles? Because first we drew the vectors. The direction of vectors is very important. Is it clear? Fine. So children, look at here. These two are homework for you. Come on. Just these are the homework questions, homework. Okay, no, it's not like homework, it's like a practice. Okay, na. So just go through this. So how you can write the direction for this, and for this vector A and vector B, just write your answers in the comment box so that we'll go through it. Is it clear, children? It's very small session, it is very small, and in detail we discussed. Okay, na, fine. Just go through this again. So children, previously just we had almost 3 to 4 vector classes, which links will be given in the description. Just go through it, and the very next class we will be discussing about the resolution of vector. Okay children, thank you very much.